In this video, we're going to be discussing word problems where we can set up an equation using a variable to help us solve. So we have 4 steps we're going to follow to help us do this. The first step is to define the variable. The variable is the letter that is representing the unknown value. Next thing we're going to do is we're going to set up an equation based on the given information and using our variable that we defined. Next, we're going to solve the equation, and then we'll be able to answer the question in context. Let's take a look at a couple examples. So this first example, we're looking at Gina. She orders bagels for her soccer team. She gets enough bagels so that everyone on the team can have exactly one, and it costs $65 total. Each bagel costs $3.50. The bagel shop has a delivery fee of $9, and what we want to know is how many players are on her soccer team. So that is our unknown value, is the number of players on the soccer team. So that is what we are going to define our variable as. So we can use P to represent players. More specifically, P is representing the number of players on Gina's soccer team. And so now that we've defined our variable, we can take a look at the information and use that to set up an equation. So the first thing we want to look at is we want to look at the cost of the bagels altogether. So we know that if the bagels cost $3.50, then we would multiply that by the number of players on the team, right? And that's our variable P. So $3.50 times P is the total cost of the bagels. So the way we'd write that mathematically is 3.5P. The next thing we want to do is we want to consider that there's also that delivery fee that needs to be added on. So after 3.5p, we're going to write plus 9. And then that is going to represent the total cost of the bagels and the delivery fee together. And we know that that total cost is $65. So we're going to set that equal to 65. Now that we have our equation, we're going to go ahead and solve. So the first step here is to subtract 9 from both sides. Gives us 3.5p equals 56. And then we're going to divide both sides by 3.5. Do some scratch work off to the side. 56 divided by 3.5. Now this is a little bit tricky because we're dividing by a decimal. So a technique that we have here is we can move the decimal so that we're no longer dividing by a decimal. So what this means is if we look at 3.5 here, if I want that to no longer be a decimal, I would need to move the decimal one place to the right. We're allowed to do this so long as we move the decimal in both numbers. So if we look at the 56, we need to also move that decimal one place to the right as well. The decimal here would be right after the 6, so if we move it one place to the right, we're going to have to add a 0, so it now becomes 560. So our new division problem that we're looking at is 560 divided by 35. Right, so 35 goes into 56 one time. 1 times 35 is 5. Subtract, we get 21. Bring down the 0. 35 goes into 210. This one is where it's going to be a little bit trickier. We want to kind of make a good guess here. You probably don't know off the top of your head exactly how many times 35 goes into 210. If you think about 2 times 35, that'll be 70, which is still less than half of 210. So we're probably going to want to guess a number that's not too high, but also not too low. A good guess might be 6. So let's try that. 6 times 35. 6 times 5 is 30. 3 times 6 is 18, plus 3 is 21. So we ended up getting it exactly correct on the first guess. Had the number we had gotten been too high, we could have tried 5 instead of 6. Had it been too low, we could have gone up to 7. But a lot of times you just want to start with an educated guess and then go from there. All right, so 6 is our number. And it's exactly 6 with no remainder. So now we can finish solving the problem. We say that P equals 6. And so to answer the question in context, that means that there are 16 players on the soccer team. Let's take a look at another example. So here, we're looking at a math teacher, and she tells her class that she has a secret number. She tells the class, she doesn't tell them what the number is, but she gives them a hint. She says, when I multiply my number by 4, and then I add 5, and then I divide by 3, I end up with the number 11. We want to figure out what the teacher's secret number is. So again, very first thing we want to do is define our variable. The variable is the unknown value, which in this case is the secret number. So we're going to say that n is our variable, and that's going to represent the secret number. Right, and so then what we're going to do is we're going to follow along with all the operations that the teacher lists out. So the first thing she does to n is she multiplies it by 4. So we write that as 4n. And then she adds 5 to that amount, so we're going to add plus 5 at the end. Then she divides that entire amount by 3, so that entire expression needs to be divided by 3. And we're told that that is equal to 11. So now to solve this equation, we want to, essentially we're undoing all the operations. So the first thing we need to undo is the divided by 3. And we can undo that by using the inverse operation, which is multiplying by 3. So multiply both sides of the equation by 3. We're left with 4n plus 5 equals 33. Next, we're going to subtract 5, right? We want to undo the plus 5. So subtract 5 from both sides. We get 4n equals 28. And then the very last thing we need to do is get rid of the times 4, and we can do that by dividing by 4. And that gives us n equals 7. Right, answering the question in context, well, we said that n represents the secret number. So our final answer here is that the secret number is 7. All right, let's take a look at one more example. So this one is going to be a little bit trickier. So we really want to pay attention to the details here. So James is making lemonade. He has 11 liters of lemon juice. His recipe requires that lemon juice is mixed with water so that the lemon juice is 40% of the total mixture, with the remaining 60% being water. We want to know how many liters of water need to be added if he wants to use all 11 liters of lemon juice. So the unknown value that we're going to need to assign a variable to is the liters of water. So we can let W represent how many liters of water need to be added. So we know that the total amount of liquid is going to be water and lemonade, or lemon juice. And so we know that we need to combine the 11 liters of lemon juice with our unknown amount of water. So to write that out, it's going to be W plus 11 is going to be the total amount of liquid, right? The liters of water combined with the 11 liters of lemon juice. The next thing we want to do is we want to think about how much of it is going to be water, right? 60% is going to be water. So if we take that expression and multiply it by 0.6 is 60% as a decimal, right? That's going to represent 60% of our total amount of liquid. And we know that 60% of that liquid has to be water. So we're going to set that equal to W. So this is our equation that we then want to solve. Anytime we see that we have parentheses with a value outside, that's indicating that we need to multiply that value. And to do that, we use the distributive property. So 0.6 times W is 0.6W, and then 0.6 times 11. So 0.6 times 11, 6 times 11 is 66, and then 1 decimal. So it becomes plus 6.6. equals W. Next thing we want to do is notice there's W on both sides of the equation. We want W just to be on one side. So let's go ahead and subtract 0.6W from both sides. So that leaves us with 6.6 equals 0.4W. And now we need to divide both sides by 0.4. So again, off to the side, let's do 6.6 divided by 0.4. We're going to want to get rid of that decimal. So if we move the decimal one place to the right for both of those values, that gives us 66 divided by 4. 4 goes into 6 one time. 6 minus 4 is 2. Bring down the 6. 4 goes into 26 6 times. 6 times 4 is 24. When we subtract, we get a remainder of 2, so we're going to want to figure out what our decimal answer is. So we'll bring down a 0. 4 goes into 25 times. And now we have no remainder, so our final answer here is 16.5. So 16.5 equals W, right? To answer in context of this situation, that means that we need 16.5 liters of water, right? Since that's what we said W represented was how many liters of water we needed.